Hi guys, let's go ahead and start on the section 1.3 notes. And notice this section we're talking about the complex numbers, so which means we're talking about the square root of -1, which is I. And I know a lot of you should have already seen these before, so let's get started. Alright, so just some basic definitions. Again, I equals square root of -1, and I squared equals -1, because if you think about it, you have I equals square root of -1, and when you square both sides, right? When you square both sides, notice, so you get I square equal, and the square and square root cancel, so that's why you get -1. Okay. Now, I want to just point out that figure out what's this. I to the third, I to the fourth, dot dot dot, I to the n. There is a way to figure it out. So if you remember how to do it, great. If not, I would like you to try to find a pattern for it. Okay. We can talk about the pattern for this in a little bit, but for now, I just kind of want you to keep thinking. Okay, complex numbers is any number that can be written as a plus bi, where a and b are real numbers, and I equals square root of -1. So technically, what we could do is we could actually write this as this. Well, let me go back. Is 3 a complex number? Right? The answer is yes. Because 3 equals 3 plus 0i. Okay? So in this case, right, 3 can be written as 3 plus 0i. So that brings us to the next thing. A complex number has two parts. So if you think about a plus bi, so we have a real part, and then we have a complex part. A real number is basically when the complex part equals 0. Okay, so technically a real number is a complex number. Right, but a complex number is not necessarily a real number. So just kind of keep that in mind. Complex conjugate. Notice a plus bi versus a minus bi. Only thing that's different is the signs. One's a plus, one's a minus. Okay, you have done something like this back in factoring. For example, a squared minus b squared is the same as a plus b times a minus b. These are conjugates. Okay, so it's something that you have seen before, but this time we just want to kind of extend it to complex numbers. Okay, adding, subtracting complex numbers. So basically all we do is we add and subtract like terms. So we are going to add all the real parts together, and add or subtract the complex parts together. Okay. Multiply, divide. Now for multiplication, basically we're going to multiply, because this is very similar to x plus 1 times x minus 2. Something like that, right? Where we can FOIL. Okay. The division. Now the division is going to be a little bit awkward. Now we're going to do the division problem. I'm going to show you how to do it by hand, and so we know the reason behind it. But for most part, we'll be doing it with a calculator. All right. I'll show you how to use that on your TI calculator. It's fairly straightforward. The absolute value of a complex number. So absolute value of a plus bi equals square root of a squared plus b squared. This is very similar to Pythagorean theorem. Okay, we'll talk about the reason behind it once we get to the problems, but I just want you to keep that in mind. Alright, let's go ahead and move on to the actual examples. Okay. Alright, so we're going to have to simplify some radicals, because complex number, the I is square root of -1. So let's work with some of that first. So if we're trying to simplify square root of negative 98, first thing first, we need to separate the negative and get it out of here. Right? Remember this property? Square root of AB equals square root of A times square root of B. Right? This will work. We're gonna use this to get rid of the negative 1. And once you get that negative 1 out of there, the rest is pretty straightforward. Square root of 98 is just square root of 49 times square root of 2. And in this case, square root of 49 is 7. So our final answer is going to be 7i square root of 2. Okay. Now, the book might wrote 7 square root of 2i. The reason I jammed the I between the 7 and the square root is I don't want it to look like this. Okay, notice I have a pretty sloppy handwriting, and I've got points taken off on my old work because the line was too long and it looked bad. Okay, so that's the reason why I put an I in front of the square root, so there's no chance of making mistakes. Okay, alright, the next question, negative square root of negative 72 over 25. So again, same idea. Let's get the I out of there. Okay, so you get negative I square root of. Now, if you remember how to handle square root of fraction, you square root of the top and square root of the bottom. Okay. So square root of 25 is 5, which is pretty straightforward. Square root of 72, we're going to do a little bit of side work. Square root of 72 is square root of 36 times square root of 2. Which means this is 6 square root of 2. So put it back. So if you want to, you can write this as negative 6 square root of 2 over 5i. Okay? Just remember, if you're trying to deal with negative number inside the radicals, first thing first, get the I, or square root of negative 1, out of there. Okay, very first thing you want to do is get rid of that square root of negative 1. Okay. Alright, adding, subtracting complex numbers. So for adding, subtracting complex numbers, our example, we have 12 plus 4i minus 5 minus 6i. I'm just going to go ahead and get rid of the parentheses appropriately. The parentheses around 12 plus 4i can just be dropped. And we're going to distribute the negative into here and here. So that means I have a minus 5 plus 6i. And from here we combine like terms. The real parts and the complex parts, real parts go together, complex parts go together. So 12 minus 5 is 7. And 4i plus 6i is 10i. And then we're done. Okay. Adding, subtracting, very straightforward. Just make sure you don't screw up the signs. B. 4 minus square root of negative 9 plus 3 minus, 3 minus square root of negative 25. So again, first thing first, let's work on the radical with negative numbers. This is 4 minus square root of 9 times I. I'm just going to write out very far so we don't get mixed up. plus 3 minus square root of 25i. So what we end up having is we took the negative 1 out from the radical, so it becomes an I. And so now simplify, you get 4 minus 3i plus 3 minus 5i. So essentially it becomes 4 minus 3i plus 3 minus 5i. Combine like terms, you get 7 minus 8i. Okay? Again, pretty straightforward. Alright, let's go ahead and moving on to multiply. Okay. So for multiplication, this question like this, 2 plus 4i times 3 minus I. Okay, I am going to finish this problem by FOIL. And I'm pretty sure everybody remembers FOIL. So let's go ahead and get started. First, outside, inside, last. Okay? Alright, so here we go. First, 2 times 3 is 6. Outside, 2 times negative I is minus 2i. Inside, 4i times 3 is a plus 12i. And last, 4i times negative I is negative 4i squared. Which means, combine like terms. I have 6 plus 10i minus 4i squared. Okay, now I squared. Remember, what is I squared? I squared is negative 1. So we're going to replace it, the I squared, with a negative 1. So this becomes 6 plus 10i minus 4 times negative 1. So 6 plus 10i plus 4. So 10 plus 10i is our final answer. Okay, FOIL. Use FOIL. A lot of people like FOIL, so it's not such a bad idea to remember it or refresh it. Okay. Alright, second question. So 3 minus square root of negative 25 times 4 plus square root of negative 4. So just like the previous question we did earlier, square root of negative 25, we need to handle that first. Square root of negative 25 is negative 1, 25, this is 5i. Square root of negative 4 is the same as negative square root of negative 1 times square root of 4. So this is 2i. Right, square root of negative 1 is I, square root of 4 is 2i. And from here, we're going to finish by foiling. Okay. Alright, here we go. First, 3 times 4 is 12. Outside, 3 times 2i is 6i. Inside, negative 5i times 4 is a minus 20i. And last, you have a minus 10i squared. Okay, combine like terms. 12 minus 14i minus 10i squared. And remember, I squared is negative 1. So this is 12 minus 14i minus 10 times negative 1. So which is 12 minus 14i plus 10. So our final answer is 22 minus 14i. Okay. Alright. Alright, part C. You have 2 plus 3i squared. Okay. Be very careful. A plus B quantity squared is not A squared plus B squared. Okay, this is very, very careless mistake. Okay, so please don't do it. Write it out. A plus B quantity squared is A plus B times A plus B. Okay, be very careful. Alright, so this is 2 plus 3i times 2 plus 3i. FOIL again. 2 times 2 is 4, so the first. The outside is plus 2 times 3i is 6i. Inside is 3i times 2 is 6i. And last, 3i times 3i is 9i squared. Okay, so clean things up. 4 plus 12i plus 9 times negative 1, because I squared is negative 1. So 4 plus 12i minus 9. Then you get negative 5 plus 12i. Alright, the last one, the 2 plus 3i times 2 minus 3i. Notice these are complex conjugates. Okay, so if you FOIL, let's see what happens. Two times 2 is 4. 2 times negative 3i is a minus 6i. 3i times 2 is a plus 6i. 3i times negative 3i is negative 9i squared. Combine like terms. The i's cancel. So you're left with 4 minus 9 times negative 1, which is 4 plus 9, which is 13. Okay, and notice this is kind of like difference of squares. A little bit like difference of squares. A squared minus B squared is the same as A plus B times A minus B. Okay, keep that in mind. Alright, I'm back. Took a quick break. Let's moving on to dividing. So dividing, notice that what we end up having is we now have the i's in the denominator. Okay, so I will urge you to think about conjugates. So I am going to multiply the top and bottom by the conjugates. Because when you multiply by the conjugates, the i's disappear. Okay, and since I want the i's not to be in the denominator, okay, and that means I need to multiply by this conjugate. So negative 3i on top and bottom. Okay, and be very careful. You are always multiplying by 1. Just looks different. Alright, here we go. So if I multiply by the conjugate of the denominator, so my conjugate is negative 3i on top and bottom, I end up getting negative 6i over negative 9i squared. And remember, I squared is negative 1. So I end up getting negative 6i over positive 9, and we can reduce a little bit. You get negative 2/3 I. Okay. Alright. Second question, 2 over 1 minus I. Right? Again, there is not really a division for the complex numbers, so we are just going to rationalize the denominator by multiplying the complex conjugate of the denominator. Okay, so let's go ahead and multiply the top and bottom. So you multiply the top, you end up getting 2 times 1 plus I. On the bottom, you get 1 minus I times 1 plus I. The top is pretty straightforward. You can distribute 2 times, so this is 2 times 1 plus I, and you get 2 plus 2I. Denominator. Okay, if you think about a squared minus b squared is a plus b times a minus b. So in this case, we can use this idea and just multiply it out really quick. So 1 minus I times 1 plus I is the same as 1 squared minus I squared, which is 2 plus 2I over 1 minus a negative 1. So 2 plus 2I over 2, which means this becomes 1 plus I. Okay, it becomes 1 plus I. Now, if you want to check with the calculator, you can actually use it. The I button is second the decimal point. Okay, that will give you the letter I, and then you can punch that in. I don't have a way to adding some videos on here, so if you have any questions, feel free to ask me, and I can show you when we have a Zoom meeting or something like that. Okay. All right, part C. Now you got the 2 plus I over 5 minus I. Okay, so what we're gonna do is I'm gonna show you how this would look like on the calculator. I would type in 2 plus I parentheses divided by parentheses 5 minus I, and if you punch that in the calculator, you should have this as a result. I'm going to punch it into my calculator right now. You should get something like 0.346153 plus 0.26 blah blah blah. So once you get that message, next I want you to hit is math fraction. Okay, fraction, math fraction. We're going to turn this into a fraction. And if you do that, you should see something like and when you hit enter, you should get 9 over 26 plus 7 over 26i. Okay. Mechanically, this is what they're doing. and then you have to foil the top and then foil the bottom. Okay, it just gets a little messy. So calculator will help. All right, so I'm just showing you what this would look like with the calculator. But if you were to do it by hand, you're gonna foil the top and foil the bottom, and then we're gonna clean things up. So, all right. The last part, absolute value. Okay. Earlier, I said that this is going to be like a Pythagorean theorem. The reason is this. You may not see it in this class, but in reality, a complex number, we can treat it like an x and y. So if we treat this on the graph of real versus complex, the 5 plus 12i is actually 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that means I have a triangle. So this tells me that I can draw a triangle where this is 5 and this is 12. So the magnitude is the hypotenuse. So that's why this problem will be done just like a Pythagorean theorem. Okay? So this is going to be quantity square equal 5 square plus 12 square, and that's why the formula looks like this. And which is square root of 25 plus 144, which is, I ran out of space again, square root of 169, which is 13. Okay. So yeah, if you have taken trig, this is a vector. Okay, this is essentially a length of the vector if you have taken trig. Okay, but if you haven't taken trig, that's okay. But this is the idea behind it. It's more physics than anything else. Okay. All right, so same idea. 4 minus 3i. This is just same as 4 squared plus negative 3 quantity squared. So square root of 16 plus 9, which is square root of 25, and that is going to be 5. So graphically, what that means is I have 1, 2, 3, 4, and 1, 2, 3, but negative 3. So this is the triangle that I'm looking at. Where this is 4, this is negative 3, and this right here is 5. Okay, all right, and this is it for the complex numbers. Hopefully, it's a little refresher and not everything completely new. Any questions? Again, my email whsieh@grcc.edu, or you can call 616-234-4729, or catch me on Zoom meeting. Okay, our office hour from 6 p.m. to 8 p.m. Okay, I will talk to you guys later. Bye-bye.